Hey guys, welcome to Unit 6, Lesson 3. Our topic today is rates of change, and we are going to be explain the average rate of change and also find the equation of tangent and normal lines to a curve. So pause the video, try the do now or the warm up. Okay, the warm up says write the equation of the line containing the points, and 2 points are given. So going back to your equation of your equation of a line can be written in two forms. This is called the slope-intercept form because you need your slope and your y-intercept to write the equation. So that's y equals mx plus b. Then there is point slope, which is y minus y1 equals m times x minus x1. And all you need is a point and just your slope. And you can, if you simplify it, if you solve it for y, it will look like that. So I most likely will be using this equation, and you don't have to simplify it. You can just leave it in that form. So all I need to do is find my slope. How do I find my slope? My slope is change in y over change in x. So change in y, it would be 4 minus 3 over negative 2 minus 1, which is 1 over negative 3. So that's your slope. So I need to write the equation. Though I found my slope, all I need is equation. You can pick any of the 2 points. It does not matter. So I'm going to do y minus 3 equals, my slope is negative 1 over 3, x minus 1. If you were to simplify it, let's do this. Y equals, it'll be what? Negative 1 over 3x plus 10 over 3. So either or is fine. Most likely, you can just leave it in this form. That's fine with me. So the slope of a line is the constant rate of change of the linear function and can be found using any 2 points on the line, right? Let me explain this. So if I had a graph and I have a line, I can pick any 2 points as long as they are on the line, and I can find the slope of that line because it's a constant rate of change. But what happens when they're curves? But if we consider a function whose graph is a curve where the slope is not a constant, we need to use secant and tangent lines to the curve to help us describe what is happening with the rate of change. So basically, if I draw a tangent to the curve, tangent is a line that touches the curve at one point. That's your instantaneous rate of change. Instantaneous rate of change, which is actually, I don't know if you know it, it's called the derivative. And secant line is you pick 2 points on the curve and you find the slope, which is also known as your average rate of change. So this is what we're going to be talking about. If we can find the slope of these curves by finding the slope of our tangent lines or secant line, either of the two. Average rate of change. The average rate of change of a function on an interval a comma b is the slope of the secant line through the two endpoints of the interval, and we just talked about it, right? So the average rate of change for this curve would be the slope of this secant line. The instantaneous rate of change at this point on the curve would be the slope of the tangent line. That's what this basically means. So average rate of change is the same thing. F of b isn't this y2 minus y1 over x2 minus x1. It's the same thing, but now we're writing in function notation. So that's your formula. So it says find the average rate of change of f of x over this function over the interval. So the interval will always be mentioned to you. Average rate of change is basically your slope. So it's going to be f of 3 minus f of 1 over 3 minus 1. So substitute that into it. So if I substitute 3 in here, 3 cubed is 27 minus 3 is 24, minus this would be 0, f of 1, right? 1 minus 1 is 0, over 2, which is 24 divided by 2, which is 12, or I can say 12 over 1. If I'm to do change in y, I would change in x. Okay, so the equation of a tangent line to a curve, that's basically it was. To find the average rate of change, it's basically a fancy way of saying find the slope. The tangent line to a curve at a given point gives us the linear function that best fits the graph at the point of tangency and whose slope is the instantaneous, I always read it wrong, instantaneous rate of change of the curve. The slope of a curve at a point is the number. This is the number. This is how you find the slope. So it's always a number because slope is a number, right? Oops. So it's going to be m, and this is actually also called the difference quotient, right? This is the same slope formula, but now we're writing it a little differently. So how do we apply this to find the equation of a line? So write an equation, repeated this, write an equation of the tangent line to the curve, and the curve is given to us at x equals -2. First of all, if x is -2, what's my y going to be? My y is going to be -2, 5. So I want to find if this is my curve. Let's sketch it. It's a parabola at -2, 5, which will be like around here. I'm going to take it in a different color. I want to find the slope at this point. Okay, that's what I'm trying to do. So all I'm going to do is use this formula, the difference quotient, and find it limit as h approaches 0. So the first thing I'm going to do is, what am I doing? F of x plus h. That means this is f of x. If I'm doing f of x plus h means I'm substituting x with x plus h, right? So I'm going to rewrite that x plus h squared plus 1 minus f of x. I'm going to put that in parentheses, x squared plus 1 all over h. So I am going to actually simplify this part first, just this part. X plus h squared, this is limit as x approaches 0. We can either actually do it here, so it'll be what? X squared plus 2hx plus h squared plus 1 from this, right? So this whole thing was double distributing that x plus h squared. So I'm going to rewrite this here, x squared plus 2hx plus h squared plus 1. That was my first part. Minus, remember when we are distributing the negative, everything in sign gets sign switched out. Okay, so the one beautiful thing that will always happen is everything in the numerator will cancel out that does not have an h. And that's like your check, that is that right? And it did. X squared is cancelled out and the 1 and the -1 cancel out. Now what are you left with? The h terms in the numerator. So can I factor out the h? So I'm going to rewrite it as limit as h approaches 0. I'm going to factor out the h and I'm left with 2x plus h. Why do I need to factor out the h? Because I couldn't do direct substitution in the first place because then I would have a denominator of 0. So I need to get rid of that h. And by factoring the h out, I'm able to get rid of my h. And now let's apply the limit. So it's going to be 2 times 2x. So that is your definition, right? So we have not still found the equation. We want to find the equation of the tangent line to the curve. So I know my x is what? -2. So this is the equation. At x equals -2, what would be my value? What would be my slope? My slope would be 2 times -2, which is -4. So my slope is going to be -4, right? Now I still need to write the equation. I already know my slope. I already have the point -2, 5. So I'm going to rewrite in point slope y minus, I'm going to rewrite the equation y minus y1 equals m times x minus x1. So I'm just going to slide it here. This would be my y minus my y1 is what? 5 equals my slope is what? -4 x minus -2, which is +2. So that is the equation of the tangent line to the curve at point -2, 5. Okay, so let's start the next one. The normal line to a curve at a point is the line perpendicular to the tangent line at that point. So the normal line is another word for saying that the line is perpendicular. Remember, when we're working with lines, if your two lines are parallel, two parallel lines have same slopes. I'm just going to say two parallel lines. And two perpendicular, and that's the symbol for perpendicular, upside down T, or we also call it now the normal line to the curve. Two perpendicular lines, their slopes are negative reciprocal. Okay, so now how is the slope of the tangent line related to the slope of the normal line? We just talked about it. Their slopes are what? Negative reciprocal. Right? So now I want to find the equation of the normal line. It's the same idea. So if I can find the equation of the tangent line, and or not even the equation, sorry, the slope of the tangent line, and that'll help me find the slope of the normal line, and from that I can find what? My equation of the normal line. So the first thing I'm going to do is I'm going to rewrite it here. So first I want to find the slope of tangent line, just like we did in the last question, right? The slope of the tangent line. Then find, that would be my slope 1. My slope 2 would be slope of normal line, which is going to be negative reciprocal, and I already have a point, and I'm going to substitute in the equation, and that will help me find the equation. So write equation. I'm just going to write down the few steps, right? So how do we find the slope? Our definition to find the slope is m equals, I'm not going to rewrite it, so I'm going to do what? F of x plus h. So I'm going to do that here, f of x plus h. So wherever I see x, I'm going to substitute it with what? X plus h square. And that will simplify to 4 minus, if I multiply this whole thing out, I get x squared plus 2hx plus h squared. And if I distribute the negative, I get what? H squared minus 2hx minus h squared, right? So I'm going to rewrite that here. So limit as h approaches 0, it's going to be, I'm first going to write the definition so that we know what we're doing, over h. I'm going to take it here. I'm going to go down this time. So m is equal to limit as h approaches 0. F of x plus h is this whole thing. I'm going to substitute that in here. 4 minus x squared minus 2hx minus h squared minus f of x. F of x is what? This thing, just this. So minus, if I write that with a negative outside, I'm going to have negative 4 plus x squared all over h. Now see what happens. All my no h terms will cancel out. Or negative 4 and 4 cancel out, h squared and negative h squared. So what am I left with? Negative 2hx minus h squared. So I'm going to factor out my, that's my slope. H approaches 0. I'm going to factor out the h. I'm left with negative 2x minus h over h. Again, I'm going to say it. My whole goal is to get rid of my h, and that's the whole idea behind simplifying all that, right? So I cancel out my h, and I'm going to apply the limit. So what am I left with? So direct substitution, h becomes 0, so it's negative 2x minus 0, which is what? Negative 2x. So the definition of my slope is negative 2x, but at x equals, what is it? 1, it'll be what? Negative 2 times 1, which is my negative 2. So my slope m1 is negative 2. or the slope of, I would say, slope of tangent line, right? I want to find, my question says write the equation of the normal line. In order to write the normal line, I need to know the slope of the normal line. So my slope M2 would be what? What is the relationship between the tangent line and the normal line? They are perpendicular to each other, right? It means their slopes are going to be negative reciprocal. So what's negative reciprocal of, I'm going to rewrite it as over 1. It'll be what? Just 1/2. I already know my slope. I know my x point is, I'm just going to take this here, 1, and my y is going to be, all you're doing is substituting 1 in here. So 4 minus 1 square is a positive 3, right? It's basically 4 minus 1. So 1, 3. So I know my point, I know my slope, so I can write the equation. So it's going to be, rewrite the equation, y minus y1 equals m times x minus x1. That's your point slope. You can even use your slope intercept form, but I feel it's easy because you don't have to know the b, right? So you already have the point, you found the slope, so it's going to be y minus, my y1 is 3 equals 1/2 x minus 1, and that's your equation of the normal line to the curve at the point 1 comma 3. So now for the remaining of the lesson, finish that problem set. If you have any questions, reach out. Good luck, guys.